In this lesson, we're going to talk about how to memorize the amino acids. And the best way to do that is this, to simply draw it. You can try to memorize just by looking at the structures, but it doesn't work the same way as if you draw each individual amino acid. And so I highly recommend that you look at the structure and practice drawing it. And that's going to help you solidify these amino acids in your mind. You may have to draw it a few times, but if you take the time to do that, then it's going to help you to memorize it. So let's begin. The first thing that I would draw is a carbon atom. Every amino acid has a carbon with 4 bonds. On one side of this carbon atom, you have the carboxylic acid functional group. On the other side, you have an amino group. Thus, it's called an amino acid. It's the combination of an amine plus a carboxylic acid. There's always going to be a hydrogen atom, and the fourth piece of every amino acid is the R group. And so if you memorize this, the only thing that you need to change or adjust is the side chain, the R group, because that's where every amino acid will differ. So just keep that in mind. Now the first one we're going to talk about is glycine. Glycine, abbreviated GLY, is the most simplest amino acid, and it has the R group of a hydrogen atom. So that's the first amino acid that you should commit to memory. Now the next amino acid that we are going to draw is alanine, abbreviated ALA. So let's start from the beginning again. So we have a carbon, a carboxylic acid functional group, a hydrogen atom, and an amino acid functional group. So that's the basic structure of almost all of the amino acids. Now, alanine differs from glycine in that it has a methyl group instead of a hydrogen group as the R group. Now, anytime you see basically a hydrocarbon side chain, the amino acid is considered to be a nonpolar amino acid. So if the hydrocarbon chain is if the R group is mostly carbon and hydrogen atoms, then you know you have a nonpolar amino acid. It's also known as an aliphatic side chain amino acid. Now let's go over the next example. And so the next one we're going to talk about is valine, abbreviation VAL. Now for valine, it too is a nonpolar amino acid. Attached to this chiral carbon atom, it has 4 different groups. There's going to be a CH group, which is attached to 2 methyl groups. And so this is another nonpolar amino acid. It has a nonpolar side chain. And so that's the structure for valine. Now the next one that we're going to talk about is leucine, abbreviation LEU. And this one is also a nonpolar amino acid. It's going to have a CH2 group attached to a CH group, followed by 2 methyl groups. And so that's the structure of leucine. It too has a hydrocarbon side chain, which makes it nonpolar. Now the next one we're going to talk about is isoleucine. And I like to think of this as an isomer of leucine. The abbreviation for it is ILE. So first, attached to the chiral carbon, there's going to be a CH group, which has a methyl group and an ethyl group. So that's the structure for isoleucine. The next one that we're going to consider is serine. You can also write S-E-R. Now, serine is not a nonpolar amino acid, but it's a polar one. And the R group has a CH2 and an OH group. So typically, when you see a hydroxyl group, it usually makes the molecule polar. So this is a polar amino acid, which means that it can dissolve well in water. So that's serine. Next up, we're going to talk about another polar amino acid called threonine, THR. Now, this amino acid also has a hydroxy group. So the first group is the CH group, and attached to that, there's a methyl group and an OH group. So this is the polar portion of the side chain group. And this portion is nonpolar. So anytime you have a hydrocarbon, it's always going to be nonpolar. But overall, because you don't have many hydrocarbons, but you do have a polar group, this entire molecule is considered to be a polar amino acid. Now, let's move on to the sulfur-containing amino acids. And so the first one that we're going to talk about is cysteine. Abbreviation CYS. Now, cysteine contains a CH2 group and an SH group, also known as a thiol group. Now, many textbooks will say that cysteine is a polar amino acid, whereas I've seen a few diagrams that say that it's a nonpolar amino acid. So I'm going to leave it up to you to figure out that point. Now, cysteine is a special amino acid. It can form disulfide bridges upon oxidation. So that's a property of cysteine that you need to know. Now let's move on to our next example, which is going to be methionine. Methionine is another sulfur-containing amino acid, abbreviated MET. So methionine has a CH2 group and another CH2 group attached to a sulfur atom, which is attached to a methyl group. And this is definitely considered to be a nonpolar amino acid because of all of the hydrocarbons in this chain. So that's the other sulfur-containing amino acid that you need to be familiar with, methionine. Now the next one in the list will be one of the acidic amino acids, and this one is known as aspartate, abbreviated ASP. And what makes it acidic is that it has another carboxylic acid functional group. So aspartate has a CH2 group and then another carboxylic acid functional group. So anytime you see this extra carboxylic acid functional group, you know you're dealing with an acidic amino acid. It's also a charged amino acid. It's electrically charged. So anytime there's a charge in the R group, it's also considered to be a charged amino acid. Now, the second acidic amino acid that you need to be familiar with is glutamate. Now, notice the ending of the word, ate. When you see that, it tells you that the R group contains a carboxylic acid. So that's a good indication that you're dealing with an acidic amino acid. Glutamate is abbreviated GLU, and the structure for it looks like this. The only difference is there's an extra methylene group, or CH2 group. So glutamate has an extra carbon in its structure compared to aspartate. Now the next amino acid that I'm going to draw is asparagine, or asparagine. It's abbreviated ASN. Now this particular amino acid is considered a polar amino acid. And we're going to talk about why. But let me draw the structure first. So the R group for asparagine has a CH2 group, and then it contains an amide functional group. Now as you can see, the amide functional group has hydrogen bonds, like a hydroxyl group. And so that causes the side chain to be polar. And so this is why it's considered to be a polar amino acid. So if you see an amino acid with an amide functional group, know that it's a polar amino acid. And so that's asparagine. Now, before I move on to the next amino acid, I want you to compare the structures of asparagine and aspartate. Notice that they both contain 2 carbons. They contain one CH2 group and another carbon atom. Now, in aspartate, it ends with a carboxylic acid. In asparagine, it has an amide. Now, consider the similarities between the next one, which is going to be glutamine. Glutamine is going to be very similar to glutamates. But look at the word amine, glutamine. It tells you that it has basically an amide functional group. So like glutamate, there's going to be an extra CH2 group. So I'm going to put another CH2 group, and then after that, we're going to have the amide functional group. And like asparagine, glutamine is also a polar amino acid due to the hydrogen bonds found in the amide functional group. Now the next structure that we're going to consider is lysine. Abbreviation LYS. So like every other amino acid, lysine is going to have a carbon, a carboxylic acid functional group, a hydrogen, and an amine group. Now I had to redraw because I'm going to need more space to write out the structure for this one. Now in lysine, there's going to be 4 methylene groups. So we have a CH2 attached to another CH2, and then another one, and then another one. And then at the end, we're going to have an amine. So when you see an amine in the side chain of the amino acid, this is known as a basic amino acid. So if you were to put this amino acid in a solution, the pH will be above 7. If you were to put an acidic amino acid in water, the pH will drop below 7 because it's acidic. Now the next amino acid that I want to talk about that's also basic is arginine. The abbreviation ARG. Now arginine is going to be somewhat similar to lysine in that it's basic, but there's going to be some differences. Instead of having 4 methylene groups, it's going to be 3 methylene groups, and then it's going to be attached to an NH group, followed by a carbon, double bonded to an NH2 group with a positive charge, and another NH2 group. And so arginine has a lot of nitrogen atoms. It's another basic amino acid, and it's also a charged amino acid. And the same is true for the previous one, lysine. Because it had an NH3 plus group at the end, it's also considered an electrically charged amino acid. So all of the basic and acidic amino acids are charged amino acids. Now the next amino acid that we are going to consider is known as phenylalanine, abbreviated PHE. Now let's focus on the word alanine because we drew the structure already. So if you recall, alanine had one carbon atom, a carboxylic group, a hydrogen, and an amino group. And then it had a methyl group. So alanine only had one carbon atom in its R group. So what do you think about phenylalanine? Well, all we need to do is attach a phenyl group to the methyl group. So we're going to take off a hydrogen atom because carbon can only form 4 bonds. And we're going to replace the hydrogen with a phenyl group, or basically a benzene ring. So therefore, anytime you see an amino acid with a benzene ring, it's also known as an aromatic amino acid, because the benzene ring is an aromatic ring. Now, this is also a nonpolar amino acid, because as you can see, the R group contains only carbon and hydrogen bonds, so it's nonpolar. Now the next one that we're going to consider that's similar in structure to phenylalanine is tyrosine. Tyrosine has the abbreviation TYR. Now, tyrosine looks exactly like phenylalanine. The only difference is that it has an OH group. And so it has a polar portion. The hydroxyl group is the polar part of the side chain, and the benzene ring with the CH2 group, that's the nonpolar portion of the side chain. Now, I've seen some textbooks and diagrams, they would say that tyrosine is polar because of the OH group, whereas others may say that it's nonpolar because of the hydrocarbon chain. So I'm not going to say if it's polar or nonpolar. I'll leave it up to you to research that. So let me take this out. However, we do have an aromatic ring. But know that this portion of the side chain is nonpolar and this portion is polar. As long as you understand that, then you should be fine. Now the next amino acid that I would like to talk about is proline, abbreviation PRO. Proline is a bit different from the other amino acids. The other amino acids they all have a free NH3 plus group. But in the case of proline, the nitrogen is part of the side chain. So the side chain contains a carbon atom, which is basically, well, this is going to be a CH group, so let's write it that way. And then another CH2 group, and then another CH2 group. And I think, no, this is supposed to be a CH2. And then the nitrogen is attached to this CH2. And there's 2 hydrogen atoms on this nitrogen atom. Now, it still has a positive charge, but that's proline. So it's considered a heterocyclic amino acid because this ring doesn't contain only carbon atoms. It contains a nitrogen atom. So it's considered a heterocyclic amino acid. It's also considered a nonpolar amino acid because the majority of the R group contains only hydrocarbons. And this is always there for all amino acids, the nitrogen with the positive charge. And so that's the structure of proline. It's not aromatic. This is not an aromatic ring. Next is histidine, abbreviation HIS. Now, histidine is similar to the other amino acids in that the chirocarbon has a hydrogen, a carboxyl group, and also an amino group. Now histidine is going to have a methylene group rather, in its R group, and it's also going to have an aromatic ring. And I'm going to draw the line structure for this one. So it looks something like this. We're going to have an NH group here, a nitrogen on this side with a hydrogen attached to it. And it's a 5-membered heterocyclic ring. So this is 1, 2, 3, 4, 5. There's 5 atoms in that ring. And since they're not only carbon atoms, it's another heterocyclic ring. So because this ring is aromatic, there should be a double bond here, by the way. This is an aromatic amino acid. It's also an electrically charged amino acid, and it's also a basic amino acid. This nitrogen here is a basic nitrogen atom, but not this one. The lone pair on this nitrogen atom is part of the aromatic system. Now the last structure that I would like to talk about is called tryptophan, abbreviation TRP. So like the other amino acids, the chirocarbon is going to have a hydrogen, a carboxyl group, and an NH3 group, as common to all other amino acids except proline. Now, like histidine, tryptophan is going to have a methylene group, but attached to the methylene group, we're going to have 2 aromatic rings instead of just 1. So I'm going to draw the line structure just like before. So one of the rings is a heterocyclic ring, and the other one looks like a benzene ring. But both rings are aromatic. And there's a hydrogen attached to that nitrogen atom. And so that is the structure of tryptophan. And that's how it looks like. And it's an aromatic amino acid. It's also heterocyclic. And for the most part, it's a nonpolar amino acid. The majority of the R group is nonpolar. The only portion that's polar is the NH group, because it has hydrogen bonds. Anytime O is attached to H or N is attached to H, you're going to have some hydrogen bonds present. However, because the majority of the R group is nonpolar, it's mostly hydrocarbons, this amino acid is typically classified as a nonpolar amino acid, even though it has a small polar group. So that's it for this video. So for those of you who really want to memorize the structures of the amino acids, I highly recommend that you take the time to draw it. Feel free to rewind the video and draw each structure, hopefully before I draw it on the board so you can see if you have it right. So test yourself. Feel free to go back, and as I write down every name before I draw the structure, pause the video and draw it yourself. See if you can remember what each structure looks like. And that's basically it for this video. I hope that you found it to be useful. And if you do, feel free to comment or like this video. And thanks again for watching.